We are at our last session. I'd like to invite the panel speakers to come up to the stage. You all made it, or most of you made it. So this panel will talk about the future of AI, more forward-facing, and the panel will be moderated by Kari Johnson from VentureBeat. And on the panel, we have Svenja Gudell from Zillow Group, Chief Economist. Stan Humphries, who all of you have met, our Chief Analytics Officer. We're inviting Oren Etzioni, CEO of Allen Institute of Artificial Intelligence, and Anthony Goldbloom, CEO of Kaggle, now part of Google. So with that, give them a round of applause.
So hi. Again, my name's Kari Johnson, and I'm a staff writer for VentureBeat, and I have the unique privilege to routinely have conversations with people about the future of AI, and I'm very happy to be joined by our panel. There's a lot within that idea of the future of AI and all the different places within business and society it's going to touch, and so, just to get things kicked off, I was just going to ask all of our panelists to sort of go down the line and tell us a little bit more about yourself and what are the things that you're thinking about a lot right now, the ideas and issues that are, you're thinking a lot about as it relates to the future of AI.
Sure. Svenja Gudell, I'm the Chief Economist for Zillow Group. And my team works on basically answering questions that consumers find interesting in the real estate space. So should I buy or should I rent? Should I, what color should I paint my house if I want to sell it? Should I even landscape my house before I want to sell it? Anything and everything that you might think of in the real estate space. How are new taxes going to impact me next year? And all these decisions that they need to make. And I think something that I think a lot about is how data impacts us and how data impacts our decisions. And I think, just even 10 years ago, big data wasn't a thing. I remember when my school got a big data chair all of a sudden, and people started talking about how much more data is now accessible. And when we initially interviewed people for jobs, it's like, did you work with a census data set? And you're talking about, maybe hundreds of observations and then thousands and hundreds of thousands. Now we're talking millions, billions, easy, right? And so big data is really gotten to be a thing. And with that, I think the tools AI provides us with really help us analyze massive amounts of data and helps us make better decisions. And as an economist, that's what we do every day, right? We try to get to a point where we can answer questions to help us make better decisions in the future. And I think using a lot of data and the right tools to analyze that data will help us make better decisions.
Stan?
So I'm Stan Humphries. I'm Chief Analytics Officer at Zillow Group. And I've been there for about 13 and a half years. And let's see, I'm spending a lot of time these days thinking a lot about kind of the analytics enterprise, as I kind of described earlier this morning, does kind of cover everything from kind of data science and business analytics, marketing analytics, all the way up to ML and AI type problems. These days, I'm spending a fair chunk of time thinking about data assets within the Zillow Group, where data is really the fuel that drives all the goodness out of artificial intelligence, and we're trying to figure out ways to focus on data quality and the data assets we have, because that's really where a lot of the competitive advantage for these applications come from, is from the underlying data. So spending a lot of time on that, as well as we're, as I mentioned, spinning up some new businesses which kind of provide new analytic practices that we haven't had before. For example, when you actually start to buy and sell homes directly, you get involved in, up to now we've been a very virtual-based, very scalable web-based business. Now we have people on the ground who actually go and paint houses and things like that, and that's a very operationally rich area, which brings in a lot of operations research and other areas that are very interesting, as well as some areas like risk management and how do you handle holding a lot of homes and not get burned. So it's fun.
Hi, I'm Oren Etzioni. I'm the CEO of the Allen Institute for AI in Seattle. I was a professor at the University of Washington for many years. And I would say one thing I worry about a lot is how brittle AI methods are, right? So we saw examples of that. Speech recognition works great unless there's an echo. And we've all had the experience. We talk to Alexa. It understands us exactly right. You change one word and it doesn't. We've seen machine vision examples where actually you change a single pixel and it'll get the object categorization wrong. So I think a lot about how do we develop AI methods that are more robust, both to small changes in the data and also to adversarial attacks.
Anthony Goldbloom, CEO of Kaggle. I think Oren's example is a really good one, that AI methods are very brittle. That's because you're using the Alexa and not Google Home. So the thing I think a lot about is that data science machine learning is actually not such a fun job today. I like the quote, we use the quote at Kaggle quite a lot, that 80% of data science is cleaning the data and 20% is complaining about cleaning the data, which would be funnier if it wasn't sort of largely true. And we sort of feel like tooling is, software engineering tooling has improved a lot over the last 15 years. And data science tooling and machine learning tooling is at a much earlier stage. And so one thing we're trying to do, both Kaggle as Kaggle, but also we roll up into Google Cloud. So this is sort of an objective of Google Cloud more generally, is to make machine learners much more productive than they currently are, and make the job just much less of a grind. And in doing that, really helping many more people actually make use of machine learning. To use the phrase of our VP, Fei Li, our goal is to democratize AI and make it much more widely accessible.
And Oren, I was curious, I know the Allen Institute deals with a lot of different things, and you have a lot of engineers on staff, and I was reading something, I think it was earlier this year or last year, about the idea of like a Hippocratic oath for AI practitioners, and it seems, and you have the sort of the incubator. I was just curious, what kind of stuff, I mean, you touched on the brittleness of models, but what keeps you up at night? Because it seems like you guys spend a lot of time thinking about the future of AI.
Yeah, well, there certainly are things to worry about with AI. One thing is, what if China supersedes our abilities in AI? I think a world where China has AI supremacy has both economic and military implications that we might worry about. The jobs issue is enormous, right? Don't know exactly when, but retail jobs, transportation jobs, many jobs for the weakest people in society, people who didn't finish high school, didn't finish college, are at risk or under threat. So I would say, by day I'm an AI optimist, but I do have these and other things that keep me up at night.
And something we had talked about a little bit earlier was the idea of, again, touching basically every sector of business and society. To the wider panel, what are the sort of things that you feel like people aren't talking about? There's a lot of conversations around AI, but what aren't people talking about that you think people should be spending more time on?
I think people are talking about this, but it's worth mentioning, and we encounter this all the time in our daily work too, how you think about restatements and how you deal with, when we run estimates, we have an algorithm, for example, and we will tell you your house today is, with the best data that we have today, the algorithms that we chose today, is worth $290,000. Well, in 3 weeks from now, when we have changed our algorithm to develop a better algorithm, and perhaps we've gotten, the data actually will stay the same, but we have different algorithms, and then we tell you, today we think your house is actually worth $260,000. Sorry, it's been reduced in cost. How do you deal with that? You know, and here it's just your home value, which to some people that's obviously very important, to others not as much. But if you start to get into really, you know, futuristic thinking, you know, I'm thinking like Minority Report or something, like if you have an algorithm to determine someone's crime or someone is guilty of something, what if you restate that algorithm and you think you have a better one today, but what if that flips people back and forth? How do you approach something like that, right? What are the rules of the game in that scenario?
Sort of like prior restraint with AI.
Right. Yeah.
I'm happy to jump in. Were we going in order? Are we going in order?
Take it away.
I had one I'm itching to share. One thing that I worry about, you know, there used to be this concept of the digital divide between countries like, you know, first world countries that were able to invest in digital technologies and those that don't. I think that there's actually a more acute problem now emerging. You have like an AI divide, and this is something, you know, this is a concept that I think exists within first world countries. So you look at you know, companies like Zillow and Google and Amazon that are in a position to invest and hire and identify great AI talent, and the vast majority of the Fortune 500, which is not. And I worry about you know, what it means for, you know, what does it mean for companies that are not able to make use of, you know, fundamental technology? Do they ultimately end up being, you know, totally uncompetitive? And then, you know, there's the associated job issues. So that, you know, this concept of an AI divide is one that I think is something that we ought to be worried about.
I do think the training, I was remiss to say a lot of, what do I spend a lot of time these days thinking about, I was remiss not to say recruiting and hiring, because I think we all spend a ton of time on that, and it is you know, it's a really big issue of, you know, we need all this talent for ML and AI and data science and these complicated skills, and it is a very challenging environment to get that domestically. And I think now, certainly, you know, in recent years, I think the visa issues have become a little bit more complicated, and immigration issues are a little bit more complicated, and that was always kind of an outlet, good or bad, that was an outlet for our demand in that area. It's less of less capacity now, which puts more of a premium, I think, on creating domestic supply of people with these skill sets, and we really have not done a very good job of, you know, really creating a lot of supply there. I do also think there's kind of the other side of that. There's workers there's knowledge workers in the industry. I also think kind of the other side of what the technology ends up doing to industries creates another issue of jobs and training as well, which I think we spend zero time thinking about, which is that things like driverless cars and trucks and everything else, you know, even if it doesn't take away everyone's job, it makes things more efficient. We need fewer workers there, and I think we don't really talk very much at all about what's going to be required of workforces. You know, we have a unemployment program that was designed for really the manufacturing age or you know, the industrial age, where it's designed to, you get laid off, the assumption is you're going to be able to go find another job in a similar sector, maybe at the factory across the street. It doesn't anticipate that you're going to have to, you know, you were driving a car today and tomorrow you're going to have to, you know, be operating a computer, you know, engineering milling machine. So we don't have that type of longer term retraining ability at all in this country, and that's a problem.
I do think, Anthony, you bring up a really interesting point together with Stan's point, is that, you know, this concept of how will technology push us? Are we going to develop more of a wealth gap, or is it going to, you know, technology will become cheaper and therefore more accessible, and that will help everyone? So I think there's a little bit of a, you know, push-pull there, and I'm not sure who's going to end up winning on that one, just because in your world, Stan, you can easily think of driverless cars making it much easier for people to get to work, and they work in the car, and so they're able to live 3 hours from work and have, you know, a gorgeous large house and a backyard for the kids, and still work in downtown, wherever, you know, Seattle, San Francisco, whatever it may be, and that will make them that much more efficient. And so that enables people to, you know, become house rich that way, and opens a lot of doors. But will that mean that cities will only house the hyper-rich who can afford now to actually pay the premium on living in very dense urban areas that everyone else has to commute in, which that's not great either. So the wealth gap there will increase. So kind of thinking about the trade-offs between cheaper technology, making it be very vastly accessible, versus people that are able to deal with that technology and are able to use it, having a distinct cutting-edge advantage.
I'm curious, particularly the Zillow folks on the panel, as it relates to the idea of branching out or extending a metropolitan area. What do you think about this? I mean, I recall I got an email, I'm going to say about 6 months ago, from a startup who will remain unnamed, that was suggesting the idea that people should begin buying property on the outskirts of cities because autonomous cars are just going to make it like, you're going to live 50 miles further out. It'll be a better life. Do you think people should start buying? Is that a good idea?
Yeah, I mean, Svenja kind of alluded to that the interplay of what's going to happen there's a lot of countervailing forces at play there. So that's true that you can imagine a scenario where commutes will become more enjoyable because you're not actually driving. Maybe you're reading the paper, doing something else. But you can also, the other thing that will happen is that if they're driverless cars, we probably have less need for parking structures and downtown parking. And some metros, it's actually a surprisingly large number. Some metros actually have as much as 25% of the built environment in the downtown core is actually parking, which is, one, fantastic to think about. But two, if we were to have driverless cars that are moving all the time and are, warehoused on the edge of the city when they're not in use, then that frees up all that space downtown for redevelopment and for housing units, presumably. So that's you could say it's going to be boom years for the downtown core, not for the periphery. And I do think that driverless cars do provide some really interesting options for making commutes, perhaps longer. I do think that, the more rational strategy typically for that is some type of higher speed mode, like light rail or something, and then you're using driverless cars for kind of that last mile problem. Driverless cars, sure, for point to point, for 100 miles, maybe it probably beats a bus. I'm not sure it's cost competitive with a bus, but getting 2 miles to a light rail place and then going 100 miles an hour down to some other place and using driverless cars for that last mile down there makes a lot more sense. But yeah, I think it is going to have a lot of unanticipated. It's hard to say what the impacts are going to be. Like I said, it's going to release a lot of housing supply in the downtown core, and it's also going to make a lot of the outside areas more attractive.
Well, and I can tell you, if artificial intelligence can solve the problem of having elevators go through buildings that are 200 stories high, we can have very dense urban areas.
Noted. There was a report out last week, I think, from the World Economic Forum that said that AI is going to create more jobs than it destroys. And this, I think, mirrors a Gartner study that said the same, I think, over the course of the next couple of years. I'm curious what the panel thinks about that sort of, which of those two sides of the fence do you fall on? Because at the same time, there's some very highly cited studies that are saying 30 to 40% of jobs will be automated away within the next couple of decades. Where do you think we are in terms of the progress of AI and it actually destroying jobs or creating a surplus of jobs?
Take a crack at that.
Well, one thing, sure. I mean, one thing I would say, it is very difficult to foresee the future and not the far future, right? If you think of the jobs probably that everyone in this room has, and I don't know, graphical designers, et cetera, those are jobs that one might not think about or anticipate 10, 20 years ago, et cetera. So I think it's very difficult to anticipate for the long term. But again, the people that I worry about are there people who don't obtain computer literacy. I don't think we're going to have automatic programming, which was a dream of computer science and AI many years ago, for a very long time, right? So people are going to need to have the ability to use computers very effectively analyze data very effectively. Not everybody has to be a programmer, but engage in that kind of analytic thinking. And there's a set of people who aren't set up for that. There was an article a while ago talked about these coal miners who became data miners, right? But that isn't the reality for most people. So even if jobs are created, the distribution is changing, and that's a huge thing to worry about. The one ray of optimism, again, I've recently heard some of the statistics from Hadi Partovi about code.org, and so we do seem to be making headway in increasing computer literacy here in this country and worldwide, which is a great thing, but still a lot to worry about.
I agree with Oren. It's very, very hard to predict. Oren gave the example of designers, which is a nice one. The one I like is personal trainers. Like, who would have guessed that, personal trainers, as I understand it, almost barely existed 30 years ago. It's actually a decently large profession now. Who would have guessed? And it's not a profession where you need to be computer literate. So the question is, like, are we going to create more professions like that? And it's super hard to predict, right? I mean, one reason to be optimistic is humans are really pretty adaptable, and you look back through time, and we've had technological disruption, perhaps not at the pace that we're seeing today, but humans have always adapted up until now, and the only thing that you might argue is different now is the pace of change might be faster, but I think probably on balance I'm optimistic, but it's very hard to know.
I'm curious, Anthony, could you tell us a little bit more about, like the sorts of things that you've seen on Kaggle that frankly make you proud, because it's a very interesting platform, and what sort of crowdsource actions do you think can move the AI community forward?
Yeah, well, talking about, I guess this is the flip side of what we were just talking about, like some of the things to be excited about. Always excited by areas where, there have been times in Kaggle's history where we've been brought problems and we thought there's no way this is solvable. And there are a handful of times where actually they've turned out to be solvable. We did an essay grading competition with the Hewlett Foundation. Now this had limitations. These were all standardized essays that tens of thousands of students were given, like the same essay. But it turns out when you have when you have a large body of graded essays, algorithms are actually able to learn reasonably effectively how to grade those essays. It turns out that each of the essays in this competition were graded by 2 teachers, and the algorithm was trained to, the algorithm was being trained to match the average grade given by the 2 teachers. Turns out the discrepancy between the 2 teachers was about the same as the discrepancy between the algorithm and either teacher. Somewhat disturbingly, one of the reasons for this is actually the discrepancy between the 2 teachers is relatively large, which is, as many of us have had essays graded, that's not great to hear, but that was certainly one that was a surprise. With the rise of deep neural networks, areas of technology that people had been excited about for a long time, but weren't really meaningfully possible, became possible. For the longest time, medical imaging was an area, sort of like automated coding. It was one of those areas where machine learners always thought that, what a great use case for machine learning. There was some limited success. You could train a machine learning algorithm to identify breast cancer from mammographic density images with some level of accuracy, but it would always get thrown off, to Oren's point about algorithms being brittle. If calcites or somebody was overweight or so on and so forth, the algorithm would get thrown off. Well, with the rise of deep neural networks, Kaggle has now run challenges around taking CT scans and diagnosing lung cancer, taking images of the eye and diagnosing diabetic retinopathy, taking MRIs and measuring ejection fraction, which is a measure of heart failure. And in each case, we've been able to match, or in some cases where you have a better ground truth, actually improve on the diagnosis from physicians. And so that's an extremely exciting area. And I don't need to talk about autonomous vehicles that come up a lot, but obviously another area that's incredibly exciting.
I just want to add one thing because it's such a beautiful example with the essay grading. It illustrates a number of things, right? My first thought as you were talking was like, okay, and there go the teaching jobs. But really what's happening is not the jobs are going away as much as certain tasks are getting automated, right? So having been a teacher for many years, nobody likes to grade these the essays. So you can imagine, and this is happening, the mix of things you do as a teacher or as in other profession changes, and maybe at least some level of the grading is, is handed to the machine. There's still some stuff you need to do to explain to the student, what went wrong, and it's really a beautiful microcosm because, of course, often these programs look at things at the lexical level, right, at the words and so on. So students might learn to, use fancier words even though they don't quite understand. So you get into this adversarial and brittleness. So I think that example really shows a microcosm of all the issues we talked about. What's the future of grading in a world of AI?
Well, it also, it frees, if a teacher has to do less grading, it frees them up to do more creative lesson prep, for instance, right? Rather than just rolling over the same class every quarter or every semester. So that's a nice example of shifting focus.
Lesson prep while they're in the autonomous vehicle from the
Yeah.
It's also a nice analogy between the test graders and the disagreement between two graders and real estate prices. If you've ever looked at two CMAs from two different real estate agents, you will see that there's some disparity there. So,
any questions from the audience?
So this device is last year's device, and this year's device is okay, so this is last year's device. So it has like 600 billion operations per second for neuromorphic computing. This year's device does 5 trillion. And so it's like it's 8 times faster, 1/10 the power. And there's a billion people who have something like this, and they'll have something, they'll have something that has basically all of their experiences sort of flowing through this particular device. So right now that Kaggle is actually doing like one big corpus, right? And this could have like a corpora of location, conversations. You could even record memos. And so I'm just wondering, how do you take a model that can be very individual and be able to create analytics? And say if I want to create an algorithm to test, and then all of a sudden it's just not one huge corpus, it's this corpora distributed amongst millions of people. How do I get some analytics that say, okay, this works better than this other one?
Yeah, one of the limitations is just getting large enough data sets, right? I work at Google now, and even within Google, it's very hard to get access. There's a big focus on data privacy, and it's very hard to get access to large enough data sets to train meaningful models. And so it's always the bottleneck. Machine learning is not magic. It's only as good as the data that you have access to. And so while these things are capable of collecting amazing amounts of data, in practice it turns out to be fairly difficult to assemble it all and do meaningful stuff with it.
You got time for,
So today we hear a lot about racial bias, gender bias. So do you think that machine learning will reinforce, mitigate, or just reflect these biases that we have today?
That's a complex one. The most obvious places where that really goes wrong is in places where people use as training data processes that were already themselves the result of racial bias. So, for example, mortgage data where redlining was in effect, and if you were then to train models on that, not aware of the fact that the loan officers may have used racial or other types of biases to make those decisions, and then you try to train data on it, then the model's going to learn exactly what the humans were doing, which was had problems with it. So I think it does put a premium excuse me, and thinking about how you're going to structure the problem.
It's an emotional issue for a lot of people. I understand that.
Chokes me up. I should have gotten some water before I went on. But you need to think about the data that you're going to train on. And that's not to say that's like a first, that's a first order problem that you're going to run into with where biases could creep in. Biases could still creep in even after that. But
I want to add one thing. I think Stan is exactly right. The algorithm are kind of replicating and sometimes even amplifying biases that exist in the data. And the data always comes from the past, and the models we're building are always about the future. So it has very much that danger you talked about. People also complain that the models are opaque, right? We don't know what the learning algorithm was doing inside, what variables it was taking. But the other point I want to highlight is compared to what? So often it's compared to people who are making those decisions. And as Stan alluded to, and as we all know, the people are biased, and the people are not opaque. The people are opaque, right? They lie about their decisions, and the people are racist, and the people are sexist. So my point is that we want to find our way out of this, but there is the potential actually for the interplay between humans and these machines working together to get rid of a whole bunch of bias that was latent and under the rug.
This is actually an area of focus at Kaggle at the moment. We're running a competition right now in connection with Google AI that tries to unbias the training data. So one common thing is you see somebody in scrubs, for instance, and if it's a female, they get labeled nurse, and if it's a male, they get labeled doctor. Like that is a sort of a fairly common example of bias that, if you look at the majority of images, through Google image search or ImageNet or whatever, the males are doctors, the females are nurses. And what the Google AI team have done is they have worked very hard to assemble an unbiased training set so that, people in scrubs are they have the same representation where the label is doctor, where the picture is of a female and a male. And so this is an example of an effort that I'm aware of to try and unbias algorithms. And so this is something you can see on our website. If you go to Kaggle, that there is an active, this is a challenge running right now.
Thank you. Last question, then we got to go to happy hour.
All right, quick question for the panel. We've heard a lot of examples of problems where large volumes of data are required to train good models. We heard from Automata a great example of where data is sparse or unavailable, and so we need a good authoring story to create a good model. I'm especially curious to hear about your hopes for the prospects of learning tasks without large volumes of data. From small or single examples, I think humans are particularly good at this. What are the prospects for AI going forward?
Well, this is something we work on extensively because a lot of the problems, including, for example, one that we featured as a Kaggle competition, which is building systems that can take science tests and SATs, not because we want to build things that help people, help kids cheat at school, but because it's a great forcing function and kind of a grand challenge for natural language processing. Well, the number of training examples, say the number of test questions available, are very limited. And we do a lot of work on a program called Semantic Scholar, which is an academic search engine. Same thing. You can't have Turkers label the data. You need scientists to label the data, and there's only so much labeling that they'll do. So this problem arises again, and it goes back to a very old trade-off in AI, sometimes called the knowledge-data trade-off. And so the way to overcome that is if you can come up with some background knowledge of various sorts to overcome the paucity of the data. And that doesn't necessarily mean some heavy-duty logical database, back to the 70s and expert systems. So it could be pre-trained weights, right? Transfer learning, those types of techniques that are very common. But I think that the short answer, and I think short is appropriate because we're between you and happy hour. The short answer to your question is we need to use knowledge from somewhere to overcome the paucity of data.
Plus, it's not a new problem, right? We've had to deal with sparse data before and how to address that in a modeling framework, so hopefully can learn from the past and apply to machine learning settings.
Oren mentioned transfer learning, which I think is one of the most astonishing things that is possible now, where you can train on images of dogs versus cats, then you chop off a couple of layers off your neural network, and then you can use that pre-trained model to learn to diagnose medical images, for instance. And that allows you to train on, you mentioned one example where you can't train on one example, but you can train on an actually relatively small number of, small data set and have amazing results. And pre-trained models are particularly powerful for image recognition. And the reason for this is, you don't need to relearn edge detection and shape detection and all those. You can use the dogs versus cats for that and just use the medical imaging for the medical specific parts of the neural network. So that's an exciting thing. And then there's embeddings for natural language processing, which is a sort of roughly equivalent concept.
Thank you to the panel.
Let's give a round of applause.
Yep.
Great discussion. Before we go to happy hour, I want to thank all of you for attending the conference, and let's give a round of applause to all the speakers. I thought this was a great conference, and it wouldn't have been possible without them. So let's celebrate. We have happy hour somewhere over there, and look forward to